So last time we talked about where standard deviation comes from. It's a way to measure the spread outedness of our data so that you can tell the difference between two things that might have the same mean. But other than telling tech startups from fifth graders, which, let's face it, most of us could probably do without statistics, what good is knowing the standard deviation? Standard deviation has one very useful ability, and that is to exactly quantify weirdness. And that allows you to compare things that wouldn't normally be comparable. So let's go to the old proverbial standby, apples and oranges. Apples. Every apple weighs a slightly different amount, but they fall within a fairly narrow range. The internet says that apple weight is normally distributed with a mean of 200 grams and a standard deviation of 12 grams. Oranges, likewise, are normally distributed in a fairly narrow range. The internet says they have an average of 8 ounces with a standard deviation of 1.5 ounces. Put them on the same graph, and you can see that the apples have a narrower distribution. They have a smaller standard deviation, so more apples are right next to the mean. Now let's look at comparing weirdness. Which is weirder, an apple weighing 180 grams or an orange weighing 9 ounces? We can put them on the same graph. So they're both on the downslope of the curve. It looks like the orange is closer to the peak than the apple? Maybe? It's hard to see. The apple is 20 away from the peak, and the orange is more like 30 away. But the orange is a spread outed distribution, so maybe that 30 still means it's relatively closer to the peak? I mean, how would you measure that? Well, we have a measure of spread outedness. It's standard deviation. So what we can do is see which one is farther away relative to its standard deviation. As we said, the apple at 180 grams is 20 away from the mean, negative 20 because it's smaller than the mean. And the standard deviation is 12, so the apple is 1 2/3 standard deviations away from the mean. The orange, on the other hand, is 1 ounce away from the mean. Hopefully you don't need a calculator for that. And the standard deviation is 1.5 ounces. So the orange is only 2/3 of a standard deviation away from the mean. So the apple is really quite a bit weirder for its distribution. And this works for anything that's normally distributed. So find something that you like and you know really well, and find something you can get the mean and the standard deviation for it. Men's heights in the US, the average is 5'10" with a standard deviation of 3 inches. LA annual rainfall, the average is 15 inches with a standard deviation of 7 inches. Movie ratings on Rotten Tomatoes, average is 63.5 with a standard deviation of 17. What that does is allow you to compare whatever it is you're looking at to something with which you are intimately familiar. So if you're looking at something that has a mean of 120 days and a standard deviation of 34 days, and you're trying to figure out if 165 days is a weird result, that's a little non-intuitive. But that's 165 minus 120 is 45 divided by 34 is 1.3 standard deviations. So if you look at men's heights in the US, 1.3 standard deviations is 4 inches. Since we were above the mean, we add 4 inches to 5'10", that gives us 6'2", so that result is as weird as a 6'2" man. Which is to say, I mean, it's on the high end of normal. It's what you call a big result. But it's not something that would make you say, no, wait, no, we screwed something up. This can't possibly be right. It's a perfectly plausible result. In contrast, in my stats class yesterday, we got a result that was 11.3 standard deviations above the mean. 11.3 times 3 inches is 34 inches. Add that to 70 inches, you get 104 inches, or 8'8". So that result was as weird as an 8'8" man. And that's a result that should make you say, nope, something weird is going on here. Now, I've been spending this whole time saying that this or that is so many standard deviations above or below the mean. By now, your stats professor has probably started talking about z-scores. They're the same thing. A z-score is simply how many standard deviations away is it. A z-score of 0.75 means that it's 3/4 of a standard deviation above the mean. A z-score of negative 3.5 means that it's 3.5 standard deviations below the mean. That's all it means. Next time we'll talk about what you can do with z-scores, including how to use z-scores to make yourself seem smarter than you actually are. If you'd like to make sure you see that video, click subscribe. But thanks to YouTube's new algorithms, that's not actually a guarantee you'll actually see the video. Liking and commenting not only helps us spread the message to more people, it also makes it more likely the videos will actually show up in your feeds. I'm Raina Ramsey. Don't forget to be awesome, and remember, everything is interesting.